Okay, so what we're starting with today, this is the very beginning of when we start with geometry stuff. So this is angles and angle relationships.
You made math fun today.
All right.
Yeah.
So when we talk about, first of all, I'm assuming that you already know, what is an acute angle? Somebody tell me.
It's like that.
Yes. Yeah, it's 90 degrees, between 0 and 90 degrees, right? Obtuse is greater than 90, less than 180. What is a right angle? Exactly what?
90 degrees.
90 degrees. What is a straight angle? Does anybody remember what a straight angle is?
180.
Exactly 180. Okay, good. Now, some of the stuff we're going to cover, okay, we're going to cover, write this down, complementary angles, complementary. Okay, we're going to cover supplementary. We're going to cover vertical angles. Okay, adjacent. And these are all angles, by the way. When you see this, know that that means angles, okay?
Oh,
Okay, we're going to cover alternate interior. Alternate exterior. Corresponding. Okay. All right, so write all that down, and then we'll go over the definition. How many have heard of some of these? Some of you guys in my class last year, we did a little bit of complementary and supplementary, okay? So, first of all, what are complementary angles?
they complement each
Okay, two or more angles that add up to 90 degrees. Okay? So 40-degree angle and a 50-degree angle, would those be considered complementary? Yes, because they add up to 90 degrees. A 40-degree angle and a 30-degree angle, would those be considered complementary? No. Okay. Supplementary. Does anybody remember what supplementary are?
I'm guessing it's, two numbers that add up to 180.
Two or more angles. Yep. That add up to 180 degrees. Okay? You're going to use this a lot. Okay? Now, if I have a 130-degree angle, what would I need the other angle to be for them to be supplementary? 50. Okay, does that make sense? Okay. Vertical angles. Okay, these are opposite angles in an intersection, and they have the same measure. Okay? Does anybody know what adjacent angles are? Okay, angles that share a side. Angles that share a side. Okay. What about alternate interior angles? Two angles inside an intersection that are complementary or supplementary. And I'll go over some examples of these in a minute. Okay? It'll make it a little bit easier. But specifically what we're going to talk about with alternate interior angles is when there is an intersection of parallel lines. Okay? Which forms a transversal. I'll show you what that means in a second. God bless you. Okay. So what do you think alternate exterior angles? Angles on the outside. Okay? Angles on the outside of an intersection and they are complementary or supplementary. Okay? All right, and the last one is complementary or corresponding angles. Okay, these are angles in an intersection that have the same measure. Okay. All right. Does everybody have all of that written down?
Definitely.
I saw from you one.
It was invisible.
Okay, come on. You got it. Everybody else has to take notes. So do you. Okay, so when we have, let's identify some of these. Okay. When I have lines here. Okay, if I have an, let's say I have an intersection here. And actually, let's do something like this. Okay, first of all, that's an intersection. That's a perpendicular intersection. Okay, and what perpendicular means is they form a right angle. Okay, and the way that you see this is perpendicular. Okay, you're going to see that written as, okay, let's say that I have another line, let's say right here. Okay, and there is a, what is usually the sign for a right angle? Does anybody know the sign for a right angle? Andrew? Yeah, there's like a square. If you see a square, like right here, that means that these two angles form a right angle. Okay, so if these two angles form a right angle, what are they? They're complementary, right? Okay, so this is an example of a complementary angles. All right, and if you saw that, let's just say this was angle A and angle B, regardless of what they are, okay, you can tell that those two are complementary because those two angles together form a what? A right angle. Okay? Okay, these two together form a right angle. Okay, they also share this side. So what are angles that share a side? Adjacent, okay? This angle A is adjacent to angle B, okay? Does that make sense? Now let's say that angle A had a measure. Let's say this was 30 degrees. Could you find out what B is? B would be what? 60 degrees, okay? Because these two together would add up to 90, okay? Does that make sense so far? Okay, all right. Does everybody have that written down? Okay, so when I have an intersection that looks a little bit different, all right, tell you what. Let's say I've got an intersection that looks like this. And I wanted to know, I have angle A here and angle B here, okay? What do you think these two angles, they're formed along what? See how you have this straight line? That means these two angles together have to equal what? So if they have to equal 180 degrees, what does that make these two? Supplementary, okay? So these are supplementary angles. Okay, because these two, now if this one was, let's say, 140 degrees, what would this one have to be? 40 degrees. Okay. You with me so far? All right. What, okay. When you see the word, does everybody have that written down? Okay. So if you see the word vertical angles, okay, any kind of an intersection, it doesn't matter what the intersection looks like. Okay, let's say I have an intersection like this. Okay, whatever measure, these are what we call vertical angles. And if you look back at your definition of vertical angles, what does it say is the definition of vertical angles? Opposite angles in an intersection have the same measure. So, if, let's say that the measure of this angle was 130 degrees, okay? What do you think the vertical angle is to that? What is the measure of this? This is also 130 degrees, okay? Those are what we call vertical angles because they're on opposite sides of this intersection, okay? Does that make sense? Now, let's say that the measure of this angle was 50 degrees. What is the measure, what would its vertical angle be? This one would also be what? 50 degrees. So when you have an intersection, and it doesn't matter what it looks like, whether it's perpendicular or just an intersection like this, any intersection, if you have one measure, you think you can find all the other measures. Look, check it out. Let's just say I have one measure. Let's say this one measure, let's say this was 120 degrees. Do I have enough to find all the other measures here? The first one's easy, right? Because the vertical angle, this would also be what? 120 degrees. But I know even, okay, check it out. This is a straight line. Even though it's kind of curved upwards, is this still a straight line? It is. That means that these two together have to add up to what? 180. So this is automatically going to be what? 60 degrees. And because of the vertical angle rule, the opposite side of this is also going to be what? Okay, so I only had one measure there, but I found all the other measures, didn't I? Didn't I? Okay. So let's just say that I gave you a measure here. Let's say this. This was 40 degrees. Can you find all four of the other ones? I mean, all three of the other ones. You can, because this one would be what? 40. This one would be what? 140. This one would be what? 140. Okay, does that make sense how we use vertical angles to solve for missing angles on an intersection? Okay. All right. Very good. Now, you understand what adjacent are? Okay, alternate interior. Okay, when we have a set of parallel lines, what does parallel lines mean? What does that mean? They're never going to intersect. These would keep going on and on forever, and they would never intersect. This is an example of parallel lines. Okay, now when we have a line, and write this down, this is going to be one additional vocab term. That line right there, that intersected parallel lines, didn't it? Okay, this is what we call a transversal. Okay, that line right there is a transversal. And that is a line that intersects parallel lines. Okay? Now, when this line intersects those parallel lines, how many intersections were formed right there? How many angles are formed? Sorry. Look, there's one here, 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 here. How many is that? That's 4, 5, 6, 7, 8. A transversal, when it intersects parallel lines, produces 8 angles. Okay? So, what we have, if we had one of these measures, do you think we'd have enough to find all the other ones? Why? Because these are parallel lines, whatever this is, let's say that this was 120 degrees. Obviously, we already have what? We have this one. What are those called? Vertical angles, right? Okay, so this one will be 120 degrees. However, we also know that what? That's 120 and this is 120, right? Okay, the reason being, okay, because that intersected parallel lines, these are going to form the same angle measures. Okay, does that make sense? So this, if this is 120, what's this going to be? 60. And all of these, this one's going to be 60. This one's going to be 60. This is going to be 60. Okay, you understand that so far? Now, what is formed by these, all these angles. Okay, let's say that we have angle A and angle B here, okay? If I don't have any measures, I can't figure out what they are, unless I measure them with a protractor. But if I have one of these measures, I can find the other one, can't I? Okay, these, A and B, are what we call alternate interior angles. Okay? Alternate interior angles. Okay? Well, if I have C and D, what do you think those are? Alternate exterior angles. Okay, because these angles are on the outside of the intersection. Does that make sense? Does that make sense? Alternate exterior angles, because they're on the outside of this intersection. Okay. Now, let's think about this for a second. If I knew the measure of angle A, okay, let's just say this is angle E, F, G, and H. Okay. Pick one of those. Linear, pick one of these angles. I don't care which one. H. Okay. H. Which angles are going to be the same measure as H? G. What else? G, D, and B. Okay. So those are what we call corresponding angles. Okay. If I said G and B, those are corresponding. Why? Because they have the what? They have the exact same measure, okay? G and B are corresponding. Okay, because they have the same measure. Let's say G was 150 degrees. I automatically know that what's also 150 degrees? H, B, and what? And D, okay? Does that make sense? So give me another corresponding pair of angles here. Give me another one. Andrew? E and what? Well, E and G, those are alternate exterior angles. But what about these? Are they corresponding? A and E, right? Okay, one's outside, one's inside. Okay, what about what's something that corresponds with F? Okay, F and C. Yeah, do you understand what corresponding sides are now? Okay, so if I was to give you a measure, let's say I gave you a measure of angle C of 35 degrees. Could you figure out every other angle in this intersection? Yeah. Well, first of all, if this is 35 degrees, what do I also know? That what? This is 35. What else? This is 35. Why? Because they are corresponding. Thank you. Okay, so I already know most of this. How can I figure out what G is? These two have to add up to what? Everybody. These have to add up to what? 180. Because even though this is going up like that, is it still a straight line? Yes, it is. Okay? So that means from here to here, 100 what? 145 degrees. You guys agree? So that means from here to here is what? From here to here is? And from here to here is? Good. Okay, so on your worksheet, you're going to have to find missing measures. That's pretty simple, isn't it? Okay? However, did everybody get that copied? I know a lot of notes today. All right. What if I have an intersection that looks like this? Okay, let's say I've got an intersection that looks like that, and all I'm given, let's say that this is B, let's say this is 70, okay? I don't know what these two together are, do I? Because why? These are not a what? There's not a right angle there, right? And there's not any vertical angles to go by, okay? But what if I was given one more measure? What if I was given the measure of this angle out here, okay, and let's say that that was 240 degrees, okay? Do you think I would have enough to figure this out now? Well, what's keeping this circle from being complete? These two angles, right? If this was complete, what is the angle measure of a complete circle? 360. Okay, so I know that this plus this have to equal what? Okay, so I'm going to write this out. 360 equals, what do I know? This is 70 plus what? Plus 240 plus what? Plus b. Okay, so in order to find out what b is, I need to do this, and this is just an equation with one extra step, right? Okay, what is 70 plus 240? 310 plus b. Well, what is b, what is keeping b from being by itself? That 310. How do I get rid of 310? Subtract 310 from here. Subtract 310 from here. What is left? So 50 equals b. So did I find the measure of this one? And these three together, do they add up to 360? Yes. Okay. Does that make sense? Okay. Not that difficult, is it? Okay, you're going to see some like this. You're going to see some that are transversals. You're going to see all kinds of intersections, but everything you need to solve for an intersection is there. Okay? Do I need to do any more examples, or are we good on this? Pretty easy stuff, right?